Good morning, children. So, welcome back to the online session of the physics class. So, we are discussing about the lesson, light lesson, that I am giving the answers for the exercise questions. So, in the last class, I had explained about all the multiple choice questions. Up to 8 questions I have answered. So, out of 8 questions, 6 questions will be the multiple choice questions. So those questions will be very important for the MCQs questions as well as the 1 marks question. So then after that, 8th question also I have explained. Then I had left out the 7th question. Okay. So for that 7th question also I had sent the answer today. I had sent the PDF copy. You just go through that and copy that in your classwork. I'm going to explain that answer for the 7th question. The question is, we wish to obtain an erect image of an object. So we wish to obtain an erect image of an object using a concave mirror. Using a concave mirror. So whenever they are saying that concave mirror and an erect image, when you will be getting an erect image in the concave mirror. So you know that in the concave mirror we have 6 positions. Beyond infinity, beyond C, at C, between C and F, at F, between F and P. So we have 6 positions. So out of 6 positions, in all the 5 positions, we will be getting a real and inverted image. You know that at infinity also, at the center of curvature also, between the center of curvature and principal focus also, at the principal focus also, you will be getting a virtual image. Always you will be getting a virtual and real and inverted image. Real and inverted image. You can take that table and you can observe that in the concave mirror in all the 5 positions you will be getting a real and inverted image. In only one position you will be getting a erect image, virtual and erect image. When you will be getting a erect and virtual image, when you are keeping the object between principal focus and the pole. If you are keeping the object between the principal focus to the pole, in between those two points, you will be getting a erect image. The question is, we wish to obtain an erect image of an object in the concave mirror. Okay. Of focal length 15 cm. They have given the focal length 15 cm. What should be the range of distance of an object from the mirror? So what will be the range of distance? What will be the range of distance of an object from the mirror in order to get the erect image in a concave mirror? So what will be the range? So range will be between principal focus and pole. Here the principal focus, I will write a rough diagram. This will be the concave mirror, principal focus, pole, focus, then center of curvature here. So when you are keeping object between principal focus and pole, you will be getting a what? Erect image. You will be getting a erect image. So what is the focal length? The focal length in the sense the distance between principal focus to the pole is nothing but the focal length. So this is the focal length. The distance between these will be called as the focal length. So here the question is, in order to get the erect image, what will be the range of distance of an object to the mirror? So the range of distance, focal length also they have given in this question, that is 15 cm. Focal length will be 15 cm. That means the distance between principal focus and the pole will be 15 cm. Okay. So focal length they have given 15 cm. So what will be the range of distance? The range of distance will be 15 cm. That is 0 to 15 cm. 0 to 15 cm. The range of distance is 0 to 15 cm. If you keep the object between 0 to 15 cm, you will be getting the erect image. If you are keeping the object beyond 15 cm, that means at F only, you will be not getting erect image, you will be getting a inverted image, right? If you are keeping the object here, what will happen? Since it is a concave mirror, you are keeping the object between C and F, you should be getting real and inverted image only, right? So when you will be getting erect image, when you are keeping the object between pole and principal focus. So that is the range of distance is 0 to 15 centimeter. You should keep the object between these distance only 0 to 15. Then only you will be getting a erect image. Okay. So that is the answer for this. What should be the range of, what is the nature of the image? Nature of the image will be, it is a virtual and erect. Okay. So that is the nature of the image. Is the image larger or smaller than the object? We'll see, we'll write the diagram for this and we will discuss about whether it is large or smaller. Draw a ray diagram to show the image formation in this case. They are told to write the ray diagram, so that we should write the ray diagram for this by using this scale and compass. Okay. So we'll write the arc of convenient distance. So they are given that focal length will be 15 centimeter, so that you should write, you should take 30 centimeter because center of curvature will be, okay. Have taken 30 centimeter, we'll write it again. Okay, this is center. Okay, so we mark a point here and we'll join this in order to get the principal axis. Okay, so this is the pole. Okay, so this is center of curvature. I have taken how much? 30 centimeter. Why I have taken 30 centimeter? They have given focal length as 15 centimeter, right? So I have taken 30 centimeter. This will be 30 centimeter. So 30 centimeter. I have taken 30 centimeter. Why I have taken 30 centimeter? They have given that focal length will be 15 centimeter. So the distance between pole and the principal focus will be 15 centimeter. So to the center of curvature it will be double, right? So we'll locate the principal focus now by cutting it into half. So it will be having 30 centimeter. Exactly, we are having 30 centimeter. We will cut it into half. So that will be the principal focus. So this is F. Okay, and they have told me that range of the object, that means range of distance of an object from the mirror will be 0 to 15 centimeters. So I can keep the object between P and F. Will keep the object somewhere else between these two. Okay, it will this as a object. Okay, so we write one is parallel to the principal axis and other one will take through the principal focus. We will take that. I will take one ray which is parallel to the principal axis. So this is incident ray. Okay. So since it is a reflected surface, it will be getting reflected. As if it is parallel to the principal axis, that will what? That will be passes through the principal focus. Correct? That will passes through the principal focus. We write that. That will be reflected through principal focus. Okay. So this is the refracted ray. Okay. So I have taken the first one will be, if it is parallel to the principal axis, that will be reflected through the principal focus. Okay. If it is passes through the principal focus, then it will be get parallelized. After the reflection, we will take one more ray, that is this is F, right? We will take one more ray through the center of curvature. If it is through the center of curvature, it will not get any reflected, it will passes through the same point. We will take it right here through the center of curvature. Since it is a surface, what will happen? It will be passes through it will be refracted through the, okay. So the first ray I have taken parallel to the principal axis, that will be reflected through the principal focus. That is first ray. The second ray will be, I will be taking through the center of curvature. Through the center of curvature, after refraction, it will be reflected through the same path. Correct? So this is incident and this is the reflected also. Right? You can observe that these two rays are not intersecting, that means it is diverging. So I need to pull backwards, right? So let me pull backwards these two rays. Okay, this is the reflected ray. You can observe that since these two rays are not intersecting, if you pull backwards, that will meet here, right? So it will meet here. Right perpendicular to the principal axis, so that will use the image of the object. That will use the image of the object. Now this will be the object AB, will be the object. I have kept it between principal focus and the pole. Why? Because they are given that range of distance will be 0 to 15. So I have kept here, I have taken two rays, one will be parallel to the principal axis. We know that 4 standard rays in the mirror, that means in the reflection concept, if it is parallel to the principal axis, after reflection, it will be passes through the principal focus. So the other ray I have taken through the center of curvature. If it is through the center of curvature, after reflection, it will be following the same path. It will be reflected through the same path. Okay. So you can observe that the reflected rays will not going to intersect each other. They are diverging. So that I need to pull backwards. If you pull backwards, that will meet at here. Since this is the image obtained by pulling the backward rays. So this is not a real image. It is a virtual image. The nature will be a virtual image, and you can observe that this is erect. So it is erect image. In fact, it is a virtual image. And you can observe that the size of the image, it will be a larger or enlarged image or enlarged image. The explanation I have given, I have sent the notes, go through that. So this is the ray diagram for that. After that explanation, you should write this ray diagram. Okay. So the next question is the image larger or smaller than the object? Image will be larger than the object. What is the nature of the image? Nature of the image will be virtual and erect. Okay. So this is the answer for question number 7. Okay. In the exercise, this is the answer for question number 7. So 8th question I had explained through the Zoom video. 9th question. We will go for 9th question. 9th question I had send the notes. The question is, one half of a convex lens is covered with black paper. One half of a convex lens. So it is a convex lens. One half of a convex lens. Okay, I've taken the diagram. Okay. So what they have told that one half of the convex lens is covered with black paper. Observe that the upper portion, upper half will be covered with the black paper. It is not visible, it is covered. Okay. The question is, will this lens produce complete image of the object? Verify your answer experimentally. Explain your observations. So you can observe that even the upper half is covered, then you will be having the lower half, right? So if the rays will be incident on this lower half, that will be definitely get refracted and obtain the image, right? Since we are having the lower half, the rays which are falling on this lower half will get reflected and will obtain the image. So even though if the upper half is covered with a black paper, since we are having a lower half, so the rays will fall on the lower half, will be getting reflected and they will be obtaining the complete image. So case 2, if you cover the lower half and we are leaving the upper half, then the ray which will be falling on the upper half of the lens, that will be get refracted and they will obtain the image. If you cover the lower half, or otherwise if you cover the upper half, by using the other half of the lens, the image will be obtained, the complete image will be obtained by the refracted rays of the upper half portion or lower half portion. So the explanation we have given, so you can write the explanation. So that's it for that question. So even though if you are covering the half of the lens also, you will be obtaining an image. In fact, the complete image you will be obtaining. Okay. So the next 10